Good afternoon, class. Today we're going to be looking at circles. I assume that you're familiar with the geometry of a circle, that you know what a circle looks like, and that you know that a circle has a point right there in the middle that's called the center. We'll denote that with the letter C. And the distance from the center to the outer edge in any direction, what's that distance called?
Starts with the R.
Radius, and we'll denote that as an R. We're going to take an algebraic approach to circles rather than a geometric approach. We'll assume that the center of a circle is represented using the ordered pair h comma k. H is the x-coordinate of the center, and k is the y-coordinate of the center. We'll use a lowercase letter r to represent the radius. And we have something called center radius form for the equation of a circle. Center radius form. Center radius form is in the form, parentheses, x minus the x-coordinate of the center, quantity squared, plus y minus the y-coordinate of the center, quantity squared, equals the radius squared. Realize there's a lot of letters here, but there are only two variables. X is a variable, and Y is a variable. All those other letters are going to be numbers. This isn't as bad as it might look at first. So let's look at number 2 first. Then we'll look at number 1.
Okay.
Oh, okay. We'll do number 1. Let's do number 1.
Okay, good.
They want us to find the center radius form of the equation of a circle with a center at 0, 0 and a radius of 5. Then they want us to draw the graph. So they give us the center. The center is at 0, 0. You're going to see when we're drawing the graph using the graphing tool that the ones centered at the origin are by far the nicest, okay? And the radius is 5. So, just like when I'm using the distance formula or midpoint formula, I label the values x1, y1, so forth. Here, I already know the radius. I've already made a note that r is 5. Realize this first number here is acting like h. That y-coordinate is acting like k. So center radius form, it's x minus, y minus, and we're going to square the radius. Now let's fill in those numbers. We'll start the x-coordinate of the center, h, is 0. Oh, that one's even worse. Get rid of that. The y-coordinate of the center, that's also 0. What are we going to be squaring here? What number am I going to have here? The 5, that radius. And usually once you write the equation in center radius form, there's not much you can do to reduce it or that you want to do to reduce it. Here we can reduce it pretty nicely because x minus 0 is just x squared plus, how am I going to clean up this y minus 0 squared? Just y squared equals the radius squared. 5 squared is? Here's my center radius form. Will this be the first time that we've typed exponents? Because you're going to have to type that in. Is this the first time we've typed exponents? I really don't remember. Okay, so
Click
there.
here.
X Look down at the toolbar. Unfortunately, it doesn't say, if you hover over that third box, it doesn't say exponent. It says superscript. And that's unfortunate, but that's what they mean by an exponent. And notice what we just did. You typed that x squared using, now type,
Oops, wait.
now
Right.
type the square.
Sometimes,
now hit equals. What
sometimes students will show me screenshots. It counted it wrong.
What's wrong there? Is that equals 25 supposed to be part of the exponent? No. Once you type the exponent, do a right arrow or click outside the exponent before you type the equals 25. Now, this graphing tool that they have for circles is so nice.
Click to enlarge.
And then you have to click the tool that looks like a circle. There's only one there that looks like a circle. And if you hover over it, you'll see it says circle tool. So you click there. And then the first thing it says to do is plot the center. You got to click on the center.
Upper right corner of the yellow rectangle says 0, 0.
So there's the center. And now just move the mouse around. This tool is drawing every circle that could possibly have a center at 0, 0. But you'll notice the instructions in yellow say, click another point. Well, how are we going to find another point? They didn't give us another point. What did they give us? They gave us the center at 0, 0. They gave us something else. The radius, count 5 units, either up, down, left, or right. Counting 5 units from 0, you're going to wind up. Is that where we want to be? Is that where we'd be if we counted 5 units to the right? At the order pair 5, 0? Yes. Click it. Save it to transfer it back to the original grid. Check answers. So you'll have to plot the center. And then whatever the radius is, you'll have to count that many units from the center
Either
to get the
left,
second
right,
up or down. That's right. Any questions there?
Mm-hmm.
This is
I know I've never learned this before, but this is like different than how we multiply pi, like 3.5.
no, that's a geometric approach.
Oh yeah.
We're taking an algebraic approach. He's looking
algebra,
at.
not the geometry of pi r squared.
No, we're not going to see any pi r square here. We're taking an algebraic approach, not a geometric approach.
Now I see where this is going.
Okay, but an algebra means you're writing equations, and that's what we're doing here. Look at the second one. I like this one better because it doesn't have that 0, 0. The center is at point
-1, 5.
-1, comma 5, and the radius is
4.
Radius is 4. We have the same instructions. Write the center radius form of the equation and draw the graph. Realize, they could have asked you to draw the graph and then write the equation. You don't use the equation to draw the graph. You use the center and the radius to draw the graph.
We could have done that first.
They could have said draw the graph first. They didn't. But here we go. It's x minus plus y minus and the square. What number am I going to put right here after the -1? I mean, right after the x minus. The -1. That's acting like my h, okay. What number am I going to put after the y minus? What number's acting like k? The 5, I agree. So we'll put the 5 there. What number's going to be squared? The 4. 4 squared, I agree. And there's not much you want to do to clean this up. That minus and -1, we can simplify that a little bit. What can I do with that minus and -1? Okay, good. Make it a positive. So we have an x plus 1 squared plus We have I'll just write it again as a y minus 5 squared. What can we do here on the right-hand side?
4 squared, they're just not talking. 16.
16,
Got it.
okay. For my final answer, so typing it in, you have to use the parentheses, left parenthesis, x plus 1, right parenthesis, and then the superscript square. Get out of that exponent before you type in the parenthesis y minus 5 parenthesis squared. Get out of that exponent before you type equals 16.
It just looks better like this, but it doesn't show the tools there.
No.
Well, anyway, I clicked enlarge. Circle. Oh, and what was that center? I forgot.
Negative 1, 5.
Ooh, left 1 up 5. Am I at left 1 up 5? Yes.
So left 1 up 5. Now we need to move 4 units, either up, down, left, or right. Which way?
Okay, so there it is. I'm going to move down 4.
That sounds good.
One,
So you're at 5 and you're moving down
3,
4, so you should be at
4.
1.
Left 1 up 1.
Mm-hmm.
So you plot the center, and then it doesn't matter whether you go left, right, up, or down, as long as you move over 4. 1, 2, 3, 4. Notice it'd be right there. You'd have the same circle. Up 4, 1, 2, 3, 4. And I'm not going to insult you by counting there. Okay. There.
The peanut gallery seems real bright. Is that how y'all want it? Or did I forget to lower the lights over there? Can you see this display okay?
I'm going to dim
Yeah.
it for
Oh, or do y'all want it brighter? Do you want it brighter? If you want it brighter. Number 3. Oh my goodness. Oh, it's the same type of problem, isn't it? Okay. In this case, the center is located at the point 5, negative 2, and the radius is 6. 5, negative 2, radius of 6. Well, I'll write my x minus squared, my y minus. You know, it just now dawned on me, this is one of those formulas that I don't just rewrite over and over. Maybe I should have written it for us. Here it is. X minus h squared plus y minus k quantity squared equals the radius squared. And I'm going to let y'all tell me what goes after the x minus. Here, 5. I need one of those hand models to be pointing.
I know your hands
Here.
look so. Your fingernails are dirty. Your hands look
I
like
was
they're
trying to-
100 years old.
This is
Okay,
the
I'll be
ink from
quiet.
the board, okay? Those erasers. I haven't been changing the oil in my car. It's okay, go ahead. Here, negative 2. Did I give it away with the color? What's going to go here? 6, I agree.
Not much to clean up.
Not much. X minus 5. I'll just leave that as an x minus 5 squared. What can I do with the y terms? Okay, so that becomes a positive y plus 2 squared. And on the right-hand side, we have 6 squared is 36. So I agree.
X minus 5 squared.
Now, before we go on, if I wanted to square this, if I wanted to get rid of the exponent the quantity squared, it wouldn't just be x squared minus 5 squared. What do we have to do if we have a sum or difference that we're squaring? We did this on the first day of the semester, if I remember correctly. We don't want to expand that.
But
We do
if
not,
you
but
did,
if you wanted to,
the
okay.
4-letter word starting with F, you don't just square the X and square the 5. What do?
Binomial times itself, x minus 5 times x minus 5 and FOIL, y plus 2 times y plus 2 and FOIL. Generally, that is never a good idea to expand those things. As a matter of fact, we're going to see in a few minutes that if someone does go through and expands it, they're just making a whole lot of extra work for you, okay? So it's x plus 5 quantity squared plus left parenthesis, y plus 2, right parenthesis, superscript square, get out of the parenthesis to type your equals 36. And you see you don't,
What did I do wrong?
X
Let's
minus
see.
5, oh, the x, and it's a minus 5.
Oh, yeah, it is a minus 5. You see, I wrote X plus, or I typed in X plus 5. It should be X minus 5. Okay, I can fix it and still get it counted right. X minus 5. Well, okay, this time I did it right, I think. Okay. Now, am I going to use any of this previous answer to do the graphing? Well, no. All you need for the graphing is that center and then move over, what's the radius? 6, okay. So 5, negative 2.
So we go to the right 5 and down 2. And looking at that, y'all see what I'm talking about? The way it says the coordinates in that yellow box, because some of these grids are mighty tight. You want to make sure that you're at the correct point. So we have 5, negative 2 as our center, and our radius is 6. That means you have to count 6 units, up, down, left, or right.
I went right 6, and so I'm at 11, negative 2.
That's
yes.
right. You have 5 plus 6, he's at 11, negative 2.
Back in the olden days where there were these compasses with a sharp point, you would put the sharp point down at the 5, negative 2. You'd move over 6 units. So and then spin the compass around. Did any of y'all use those in school?
I think that they were very dangerous, that sharp point.
Mm-hmm.
I think they eventually...
I think they've made them less dangerous now.
I think they put like an eraser or something that you put at the...
okay.
Oh, I think that's about the same. Go to number 6.
Oh, number 6, okay.
4 and 5 are the same as what we've been doing.
Okay.
Look at this one, number 6. They want us to graph the circle. Let's look back at my writing. Let's look at my writing on number 3.
In algebra, I've said this before, you do it one way, then you do it in reverse. That's always the truth. I mean, the pattern. You foiled,
and then you
factored.
Here, they gave us this. They've been giving us the center and the radius. We wrote the equation. Now we have to go backwards. Look at what we see. I want to make some observations from this number 3. I see a minus 5 inside the first set of parentheses. But what's the x-coordinate of the center? I see a minus 5, but what's the x-coordinate? A positive 5. I see a plus 2 here. But what's the y-coordinate? A negative 2. Because of the way the formula has those minuses, the signs inside the parentheses will be exactly the opposite of the center. Just like, look at number 2. Inside the parentheses, we had a positive 1 and a negative 5. But the center was negative 1, positive 5. The signs you see inside those parentheses will be exactly the opposite of the center. Now, this number here, what do you do to go back to the radius? Notice we took the radius and squared it. If you wanted to go back from 16, what undoes squaring? What do we do with 16 to go back to 4?
What about
Take the square root. We're undoing the squaring. Same thing here. We have an r squared of 36. How do we go back? You take the square root. So when they give you center radius form, you're going to have to change sign, take the square root. To find the center, you'll change sign. You'll use the same number, just change the sign, and then to get the radius, take the square root.
change
So with
sign,
that in
change
mind-
sign, square root?
With that in mind, let's look at number 6 again. I want y'all should be able to look at that problem and tell me the center. While I'm writing it down, y'all be thinking about this. My question is, what is the center of this circle?
And why are you thinking we need the center, Tim?
Because to graph a circle, we need the center and the radius. That radius is used to determine one additional point. So let's see. Switch to my paper. What's the center of this circle? Okay, change sign. So the center of the circle is +8 and -4. What's this radius of this circle?
2.
Okay, you take the square root of 4. The radius is equal to the square root of 4, which is 2. This is the 4 that you're using to find that radius, not the 4 in that second set of parentheses. It's that number there that you take the square root of to get the radius. Any questions? We're going backwards now. They're giving you the equation. You have to find the center and the radius.
Why?
Because that's what you need to draw the graph. The instructions say draw the graph.
And there's nothing special about this graphing tool here. If you had a compass and graph paper and you were doing this the old-fashioned way,
You'd still need
have
to know the center.
Where do I put the sharp point? Where do I put the pencil to spin it around? So let's see. Click
All
to
we're
line.
doing is drawing the graph. You click this circle graphing tool, and then it says plot the center. The center was 8, -4.
Not 8, -4. Yes.
And the radius is 2, so just move up
2 units up, or if you want to move left,
You're still
or
getting
down.
the same.
I'm going to move right. You said
Oh.
move up, but I'm
Okay.
moving right because I'm doing it at the end of the graph. See?
Mhm. Save it,
Mm-hmm.
check it.
Mm-hmm.
Number 7. Oh, it's the same type of problem. Let me write it down. And while I'm writing it down, you think about this question. What's the center and what's the radius?
And why are you trying to find the center and radius? Because
That's
How
what
do
you
you
need
graph
in
it?
order to draw a graph. Okay, switching over to my paper. What are we getting for the center?
This is one of those things where
Okay, the center.
there's not a whole lot of stuff.
I agree. Change sign. -3, -4. The radius,
4.
you took the square root of that number there. The square root of 16 gave us 4. And so now that we know the center and the radius, we can draw our graph. You click the circle tool. Then you click the center, -3, -4. Is that -3, -4?
Yes.
Yes, so you click it. And then we need a radius of 4. I'd move up 4 because that'll
Yeah.
drop you back on the x-axis.
Yeah.
Easy to count to. And check. Realize with MyLab, there are some nice features for y'all. They're going to make sure that this number on the right-hand side is a perfect square. You could have had a 15 here instead of a 16, and then the radius would have been a square root of 15, which is what, about a 3.8, I think? And you'd have to try to get 3.8 units. No, they're going to make sure that it's a counting number that you can get labeled correct, easily. And so even if you think, oh, this thing makes bad numbers for you, no, there are certain things they make much nicer numbers. If you look into the look in textbooks, they'll have a 15 there, and you'll have to sort of approximate them going about the square root of 15 units. So anyway.
Can I coerce y'all into agreeing that when you have this equation in the center radius form with the parentheses, it's pretty easy to find the center and the radius. Change the sign, square root.
Now,
change the sign, square root.
I'm about to do something. Something that I don't encourage you to do, but unfortunately it's about to get done.
You got to do it to show it.
I've got to show y'all to do this so I can show you how you're going to have to learn a new technique called completing the square. I'm going to work with this same problem here, okay? The same equation, I should say. I'm just going to continue with this thing here. I said that to square x plus 3, we'd have to write it twice. X plus 3 times x plus 3 plus y plus 4 squared. What am I going to have to do there? Write it down twice. Y plus 4 times y plus 4 equals, we have that 16. I'm going to do something with that 16 in a moment, but for the time being, I'll just leave it there. The x plus 3 squared, I wrote as x plus 3 times x plus 3 plus the y plus 4 squared, I wrote as y plus 4 plus y plus 4. Times y plus 4. Now I'm going to start foiling. First, x times x is x squared. Outer, x times the positive 3 is a plus 3x. What's my inner product? Another 3x. What's my last product? 3 times 3 is 9. Now let's do the same thing for y's. Y times first is y squared. Outer plus 4y. Inner. Okay. Last. 16, I agree. Equals a 16. And we can combine the 3x's and the 4y's. And I'm going to write that as x squared. That's a plus 6x. I'm going to leave the plus 9 there for the time being. Plus, we have a y squared. That's a plus 8y plus 16 equals 16. And now I'm going to write it in descending order based on exponents. I'm going to write the square terms first. X squared. And then the y squared. I'll write the unsquared variables. We have a 6x and an 8y. I'll write them in alphabetical order. The 6x first and then the 8y. I have a point for all this that I'm doing. And let's combine our constants. I want to get a 0 on the right-hand side. So what am I going to have to do with this 16? And so I'm going to have a 9 plus 16. 9 plus 16 is 25 minus 16. Did y'all follow that? We have an x squared plus y squared plus 6x plus 8y. 25 minus 16 gives me a plus 9 equals 0. This is called expanded or standard form, depending on what book you're looking at. I like to say expanded form. Some textbooks call it general form, yes. Expanded or general form.
But expanded is better because that means you expanded the x plus 3 squared and the y plus 4.
Unless you're trying to do some implicit differentiation in a calculus class, there is nothing nice about this expanded form. Look at this. Here, when it's written in center radius form, I can easily determine the center and the radius. Change sign, take the square root. Can you just easily look at this and determine the center and the radius? That's the big problem. Oh, some people try to come up with patterns on the x and y coefficients, but how are you going to get this 4 from the constant we have there of 9? That's the problem. What we're going to have to do is go in reverse. We're going to have to take this expanded form and create a center radius form using something that'll factor as a binomial squared. That's called a perfect square trinomial. X squared plus 6x plus 9. That can factor as x plus 3 times x plus 3, which is x plus 3 quantity squared. That's what I mean by a perfect square trinomial. Perfect square trinomial, here's one thing you want to remember. A perfect square trinomial had better have a perfect square as that last number there. You're going to have a perfect square. Y squared plus 8y plus 16. That's a perfect square trinomial. It factored as y plus 4 times itself y plus 4, which is a y plus 4 squared. Let me write that down. Let's see. Y squared plus 8y plus 16. That factored as y plus 4 times y plus 4, which was a y plus 4 quantity squared. What you're going to have to do is create perfect square trinomials. When you look at this, all you see is the x squared. You see a 6x. I guess you see the 9 there. That's just a coincidence that it's the number that you need there. Now the y squared and the 8y, we sure don't see that 16 that we need. So we need to practice creating perfect square trinomials. I think I'm just going to write some examples down and see if y'all notice a pattern. Here's an example of a perfect square trinomial. I'm going to use x's just because they don't have those tails taking up, wasting an extra line, an extra row of paper there. I'm just going to use x's. So let's say x squared, oh, I have a good one, minus 10x plus 25.
No factor that.
How can that be factored? It's a trinomial, so that's an x and an x. The last sign's a plus, so we know there's going to be 2 of the first signs, so 2 minuses. What are we going to use here? 5 times 5. 5 times 5 will give us 25, and if you add the 5s, it'll give us back the 10s. I agree. So that can factor as x minus 5 quantity squared. Let's create another perfect square. How about x squared plus
14x.
14x.
But put a plus and let's see if they can figure out what perfect square is it gonna have to be.
You think they're ready for that? I was going to do another example. Let's see. What number would we need here? What perfect square would we need to create a number so that it factors as a binomial squared?
49.
Okay, someone's seeing the pattern, okay?
I think they already knew it.
Okay. If you have a 49 there, this is going to factor as x plus 7 times x plus 7. And that, in short, is an x plus 7 quantity squared. How do we create the secret to creating a perfect square is this last number, these last numbers. You'll have the variable squared and you're going to have that middle number. You're going to have to figure out the number that you're going to use to create a perfect square trinomial. Look at these, I guess all three of these examples. What can we do? I think that this one here is the best example to see the pattern. What can we do to 14 to come up with 49? There are two things you do to 14, that number, the unsquared coefficient. There are two things you can do to come up with this number 14 that'll give us the 49. I'll get us started. Half of 14 is 7.
So
If you
take half.
Take half of 14, that gives you 7. Then what do you do to 7 to get 49?
Yeah.
Multiply it by itself. 7 squared gives you 49. Let's see, does this pattern work for 25? What's half of 10? 5. 5 squared, is that 25? Yes. What about this one? Half of 8 is? 4 squared is? 16?
Let's do one more. X squared minus.
Oh, okay. X squared minus
18x.
18x plus what? What number do we need here to make this be a perfect square trinomial?
81.
I agree. You take 18 divided by 2 is 9. 9 squared is 81. So you put the 81 there. And I'm going to skip this phase here with the two sets of parentheses. I'm going to start factoring it as a binomial squared. That'll be a variable. Then whatever that sign is, half of that number. What did you get when you took half of 18? A 9. And that's our pattern for creating perfect square trinomials.
Maybe I should let them see number 8. I hope it hasn't timed us out so they can see why we're getting into this. Look at number 8. Find the center and radius and graph it.
It's the same instruction. That number 7, we had to find the center and radius and draw the graph. But there's a big problem with number 8. 8 is in that expanded form. Notice there are no parentheses being squared. Maybe they thought they were doing you a favor when they did that, okay? But they really didn't. Here goes. Tony, what happened to our handout, our circles handout?
I didn't know that we had anything handout.
I have an old circles handout that I thought you typed up years
you
ago.
Do that when I'll
Can you go to my
print it out.
office? Maybe, I don't know that it's that helpful, but
I'll get it anyway since you want.
if I have it, I don't know if I have any copies of it, but if I do, okay, let's look at number 8. Number 8. We want to find the center and radius of this circle, and it's in expanded form. If they'd left it in center radius form, then we would have to go through doing all of this stuff. Surely the person that did this for you thought they were being nice expanding it like that. They mustn't have known any algebra of circles, so they would have known this expanded form is never a good thing. Unless you're performing implicit differentiation in a calculus class, which we're not. Let me switch over to my paper. What we need, think about how we need the problem to look. We need it to look like this. X, a parenthesis with X, parenthesis with Y, and a number squared. That's what we need. And once it's in that form, we just change sign, take the square root. The problem is getting it into this special form. What we'll do, I'm going to group the X terms together first. X squared minus, oh, wait a minute. I miscopied. What did I miscopy? Y'all see what I miscopied? I wrote a 10y. It should be a 10x. This is an x. I'll make sure y'all can read. That's an x, not a y. So I'm going to group the x terms together. X squared minus 10x. And in a moment, I'm going to add another number there to create a perfect square. So I'm going to put a little, skip some space there. And now I'm going to group my y terms together. So I'll say a plus y squared. I have a plus 4y plus, skip some space. Well, they did do something a little, they helped you out a little bit. They already have the 35 on the right-hand side. If it had been over on the left side, you would have had to move it over, but as it is, they already have the 35 on the right-hand side. We have to create perfect square trinomials. First thing you do, realize our pattern only works if the leading coefficients are 1. If they'd had something other than a 1x squared and a 1y squared, we would have had to divide through by whatever that number is to get a leading coefficient of 1. But fortunately, we have a leading coefficient of 1. What do we do to create those perfect squares? Remember this problem here? How did we get that 49? We did two things to that number there in front of x. What did we do? Half of 10. Half of 10 is 5. And then what do we do? Square it. 5 squared is 25. So we're going to add 25 to the left side. But this is an equation. You just added 25 pounds to one side of the scale. You better add 25 pounds to the other side of the scale. So once you add that 25 to the left side of the equation, you need to add it to the right side as well. Now the y terms. What number am I going to put here beside the y squared plus 4y? Perform the two steps. You start off with this 4. You take half of it. 4 divided by 2 is 2. And then square it. 2 squared gives us a 4. So we add 4 to the left and you have to add the 4 to the right also. And this is actually going to work out very nice. Very nicely, I suppose I should say, if I remember my old rules of grammar. Perfect square trinomials factor very easily. You don't have to resort to trial and error. Once you figure out that number that you add in there, then it's going to factor variable, sign, whatever that first sign is, and half of that number, whatever half of 10 was, 5. Following that same pattern, you tell me what's going to go inside the y parentheses. I'll get us started. Variable, y, sign, plus, number, no, not 4, 2. It's half of that number, which is 2. Now let's add these numbers here. 35 plus 25 is 60 plus 4. What have we got on the right-hand side? Oh, y'all are just being quiet. It's 64. 35 plus 25 is 60, plus 4 gives me 64. And now we have the form we needed. Remember I said we needed to get it in center radius form, because now we can determine the center and the radius. Who can tell me the center? 5, comma, negative 2. Remember I said change sign, change sign. What's the radius? What do you do to find the radius? Take the square root of 64, which gives me an 8. Good. Oh, I was about to box those in, but you're not going to have to type those in. The only reason you found the center and the radius is so you can do what? What do they ask you to do with this problem? Graph it. You need the center and the radius to draw a graph. So you click do y'all do that? Do y'all enlarge the graph, or do you use the actual graph, the grid that's just there sitting beside you? What do y'all use?
Oh, if you click over here, look at this. I'm learning something new.
What?
When I clicked over here, it gave me the little toolbars. So I'm going to try graphing it right here.
Okay.
Circle. Oh, wait, it doesn't give me the little yellow box, does it? Oh, it gives me a block right down here. Okay. And it doesn't talk you through. You know what?
I prefer it like that. Okay.
Circle. Plot the center, and I forgot what the center was.
5, negative 2.
Oh, heck. Look at these. They're incremented by 2, aren't they?
Yeah.
So
Be careful.
5.
And then just go down negative 2, so that's the first mark. Do y'all see where it says the coordinates up there in the yellow box for your
We
pointers
called
located?
it a yellow rectangle a week ago today. A box is a 3-dimensional figure. This is a rectangle up here. Okay?
Okay, so you label the center, and now you need to plot another point. The radius is 8.
Okay, so, I'm just going up by 2s. 2, 4, 6, 8. So I was at negative 2 on the y-axis. Oh, I think I just...
Negative 2 plus 8. Notice we're now at 5, 6. That's it. Click it.
Okay.
Save it. And check.
Okay.
I think we need to do another one of those, okay?
9.
Okay, here's another one.
You know what? Don't write that one down.
Don't write this down.
That one in particular. I'm going to say...
I don't like it when they have the same number floating around over and over.
Maybe this whole problem is this. Let me see. Okay, there.
Number 9.
Here's number 9.
X squared plus y squared minus 8x plus 6y minus 11 is equal to 0. X squared plus y squared minus 8x plus 6y minus 11 equals 0. Notice the constant is over there on the left-hand side too. We're going to have to move that constant over to the right-hand side in order to get it in center radius form. But here we go. Let me see this this little thing.
I believe it's
how to graph a circle without any pictures of circles drawn.
Way before YouTube videos, back in the 90s, everything, instead of videos, it was leaflets. We had leaflets for everything, trying to summarize. If someone said, I was absent, oh, well, here. Now, if you're absent, you watch the video. But if you can imagine a world of leaflets back in the good old 90s. Oh, gosh. Okay.
Okay, let's see, what does this thing say? The equation of a circle centered at 0, 0. That's not number 1. When it was 0, 0, you just had x squared and y squared. If the center's at hk, then x minus h squared plus y minus k squared. Okay, we've said all of that. To find the center and radius of a circle when the center radius form of the equation is given, change the sign of the number in the parentheses period with x, change the sign on the number in the parentheses period with y, and take the square root of the number on the right-hand side. I think we've said all of that,
Yeah.
haven't we? Okay, and there's an example. Now, how do we find the center and radius when an equation is in expanded form? Oh, can you blow that up a little bit
Well,
there?
yeah.
There.
But first of all, notice if you take x minus h and square it, you're always going to just get x squared, not some other number.
So if you have a number in front of x squared or y squared, the first thing you're going to have to do is divide through by that number. And I
That'll be
recall
problem
that
10.
used to happen.
Problem
It does.
10.
Problem 10, there's a number in front of x squared and y squared, and you have to divide through to get rid of that number. Then you rewrite the equation by grouping the x terms together, followed by the y terms. Then isolate the constant term on the right-hand side of the equal sign. Divide the coefficient of x by 2. Square the number found in step 3. Add the number to both sides. Repeat for the y's. Yeah, I think we've said everything here.
You know what, Tim?
Yeah, I think that's a pretty good summary, Tony. Okay.
I think it makes it look worse than looking at problem 8.
Yeah,
Looking
when
at
you look
problem
at problem
8 looks a lot easier than that little
especially
leaflet
my
makes
perfect
it.
braces that I made and
Yeah.
stuff.
Okay, let's do number 9.
I guess my penmanship, my award-winning penmanship is good for something. We'll group the x terms together. X squared minus 8x plus skip some space. I remember back in the olden days, I wanted it to say, group the x terms together and skip some space, then group the y terms together and skip some space. But one of us thought that sounded stupid and removed it, okay?
Well,
He
I mean,
didn't like it.
I wrote that up.
I know. I know it. And then I made some changes, what I would call improvements, but Tony didn't like the improvements. And so we group the x terms together, skip some space, group the y terms together, skip some space. And what am I going to do with this negative 11? Move it over, make it a positive 11.
No, Tim, you write so big, you should have had a plus green space and a plus red space over here on the right.
I do it vertically. Okay. What number's going to go inside the green space?
Half of 8 is...
Half of 8 is 4. And then what do you do to the 4? Square it. 4 times 4 gives us 16. So we add 16 to the left. And we have to add 16 to the right.
Oh. Now, if I can say something, write it out in words. Over here on the red, you take half and then square it. So what number goes in the red blank? Half of 6 is?
3 squared is?
9.
So you add 9 to the left, but you have to add 9 to the right also. Let's factor the x terms. I'll write the green parentheses and the square. You tell me what goes inside here. I'll get us started. The variable is x. Sine. I'm factoring the x terms as a perfect square.
Will it be a plus or a minus?
Minus.
That very next sign.
Variable. Sine here. Half of 8 is 4. I agree. Now let's do the y terms. There's my parentheses. I'm not saying anything. Y'all tell me what goes inside the y parentheses.
Well, I'll say something since you know. Variable y.
Sine. Be careful.
Look, it's the very
Oh,
next
did I
sign.
miscopy the problem? Look back and make sure. They won't tell me if I miscopied the problem, Toby. Okay. Make sure that was a plus 6y. Okay, it's a plus.
It's
So that's
the very next sign.
okay. It's the first variable, and then the very next sign.
Crossing lines.
And you don't think that's going to make it really messy? Y'all see what I'm saying? Variable, sign, half of that number. So variable, sign, that first sign there after the y square is a plus. And what number am I going to put here? 3, I agree. Now what have we got on the right-hand side? 11 plus 16 is 27 plus 9, 27 plus 9 is a 36.
Y'all see that pattern for factoring? Variable, the very next sign, half of that number. Variable, draw the lines together.
Variable, sign, half of that number. And it's not really a line, it's a ray. Okay, tell me the center and the radius. That's why we had to get this thing written like that, so we can determine the center and the radius. What's the center? 4, comma, I couldn't hear you. -3, okay.
Change the sign.
Change sign, change sign. Radius.
6.
You take the square root of 36, which is 6. Good. And you don't type that in. You use that information to draw the graph. The center is at 4, -3. The radius is 6.
Eventually there'll be one where you type it in.
Mm-hmm.
Click, circle, what was that? 4, -3, right 4, down 3. I'm at 4, -3, yeah. I like the way you're so fancy with your array, but you're calling a rectangle a box. It's a yellow rectangle, not a yellow box. Oh, and then moved over 6. 2, 3, 4, 5, 6.
Yep, 4 plus 6 lands you at 10 on the x-axis. That looks right to me. And check.
So no matter what, if you take that x minus h squared and FOIL it out, x minus h squared,
That's what you said.
oh, okay, you're just going to get x squared. You're not going to wind up with 4x squared or 5x squared.
If you wrote here the way we were writing the things out, where was it? X plus 3 times x plus 3. We got 1x squared. We didn't get a 5x squared or something. The leading coefficient needs to be a 1. The same thing true here. Y times y, that's just a 1y squared. You didn't wind up with a 4 or 5y squared. The leading coefficients must be 1 for these equations to represent circles. And if they're not 1, if that leading coefficient is something other than 1, then we're going to have to change it so that it is a 1. Any questions there?
Number 10.
Number 10.
Look at that. It's all.
Number 10.
It's just multiple choice, so I'll hide all those choices.
How do you do that?
I just did that.
Oh, okay.
Yeah.
3x squared plus 3y squared minus 30x minus 12y minus 30x minus 12y plus 84 gives me 0.
Oops.
Okay, let's make sure I didn't miscopy those signs.
More numbers, I guess. 3x
Because I figured y'all out. Y'all are the same way I was when I was in school. If a teacher wrote something wrong, miscopied something, I would sit there with glee waiting until they finally realized they made a mistake. Would I say anything early on? No. I'd let them figure it out on their own. And then I'd sit there with a straight face, silently laughing jubilantly. Is that what y'all are doing when I make mistakes? Remember, I have nothing better to do. I'm just an old man up here. I could sit here till 8 o'clock tonight, okay? Now, y'all might have other stuff you want to do, but I myself am having a high time up here. You may not be able to tell it, but I'm one of those weirdos that love my job. So it's something other than a 1. Whatever that number is, divide through by that number. Notice how I'm dividing. Divide every
So this is
term by 3.
an extra step
This is
that
an
you
extra
didn't do on the
step
others. And how did you know you had to do it?
because I saw that the leading coefficient was something other than 1. If A doesn't equal 1, divide through by A. The coefficient for those squares was a 3. We divided through by 3. And that's going to give us 3 divided by 3, that's a 1x squared plus a 1y squared minus, what's the new coefficient for x? 30 divided by 3, I agree with the 10x. Here, minus 4y plus 84 divided by 3. Is that a 28? Someone check my mental arithmetic. Equals 0 divided by 3. That's nice. It stays a 0. Now this looks like what we started off with a number 9. Doesn't it? It looks like number 9. We know what to do. We got to group our x terms together. I'll group my x squared minus 10x plus skip some space. And then I have a plus y squared minus 4y plus skip some space. What am I going to have on the right-hand side? A negative 28, I agree. But I'm going to have a
I liked it
maroon.
perfectly.
Oh, okay. I thought I'd try doing it your way, Tony, where I can see the merit in this doing it horizontally, but it just makes me write so small. I have to write so small. And as a penmanship award winner, it's just that's not multiple award winner.
It was what, every year, 1st through 5th grade.
I know. It doesn't do to peak early. It doesn't do. When you peak in the 1st through 5th grade and then it's downhill.
The rest of
When
the
we were
way.
young, there were these little child stars, these singing sensations called the Osmonds, and they peaked early, didn't they? Donnie and Marie Osmond, you know
They
what
don't even know
they
who you're
are?
talking about.
I personally did not care for their music, but they peaked early, just like me and my penmanship award. I'm waiting for y'all to tell me what's going to go in this first blank.
Half.
Half of, we take half of. Okay, so half of 10 is 5, and then 5 squared is 25. So we put a 25 here and a 25 there. Okay, that's a negative 28, by the way. I moved that 28 over. That's a negative sign there, not a smudge. What's going to go in the green blank? 4. 4 divided by 2 is 2. 2 squared is 4. I agree.
Also, a word about these signs. Notice how right here, he wrote half a 10. We don't worry about this negative because if we had
When you square it, -5 times -5 is going to give you a positive number. To be a perfect square trinomial, you're always adding a positive number. So that's the only thing that's significant for this last number is the number part there in the
You don't have to
middle.
worry about the sign.
You don't have to worry about the sign. The sign does become significant because it's the sign that's going to go in the parentheses. We have variable, that sign there, half of 10 is 5, plus, now, y'all tell me what's going to go in the second set of parentheses. Y, sign, minus, number, the square root of 4. Half of 4 is 2. What have we got on the right-hand side?
Just a 1.
Okay, that's a 25 plus 4 is 29 minus 28. I agree with 1. What's the center of this circle? 5, comma, 2.
Change the sign.
Change sign. The radius. Well, I guess the radius isn't that easy. We're going to take the square root of. I guess the radius isn't that hard. What did I say? That easy. Oops, wrong word.
Square root of 1 is?
The square root of 1 is?
Say 1. Yeah, okay.
So the center is at the point 5, 2, and the radius is 1.
Now circle it because that's all you're asking on this one.
Oh, it is? So we're not drawing a graph?
No, remember, it's multiple choice.
Oh, it's multiple choice. That's right.
Okay, so
the center is positive 5, positive 2, radius 1. A, B, C, or D? D. I agree.
Wow. How do you get from here to this? I mean, look at that. 5, 2,
radius
1.
1.
Oh. Okay.
And I need to stop and talk about the right-hand side of the equation. If, we said you change sign, take the square root. Suppose, in order for us to have a radius, to have a normal circle, this number here has to be positive. To be a circle, that number, the r squared, must be positive. Suppose you had x minus h quantity squared plus y minus k quantity squared equals 0. Suppose you went through the process, and that could have happened. Suppose this, instead of being a negative 28, had been a negative 29 plus 29, we would have gotten a 0 there. When you tried to take the square root of that number, what would you get? 0. So you'd have the center, but how many units up, down, left, or right would you move? 0. It's just an ordered pair. All you'd have is the center point. If you have the center radius form on the left side and a 0 on the right, then you're looking at just a center point. Your graph has only the center point. Look at this note down here at the bottom of this paper. If r equals 0, the graph is not a circle. The graph is just the center point. You plot the center, but you can't move up, down, left, or right.
So you just graph them.
So you just plot a point.
Plot the point, and that's all. Okay. What about, you get the center radius form on the left side, and you get a negative number on the right side.
Write out the word negative.
Okay, you're right. Negative. Negative. Suppose you have a negative number on the right side. You're trying to take the square root of a negative number. What do we know about the square root of a negative number?
Starts with an I.
Starts with an I. It's imaginary.
Could you have a circle with an imaginary radius? Say no. That wouldn't
No.
make any sense. If,
Notice what what we say down here. Blow it up a little. If you wind up with r equaling the square root of a negative, that means the radius is imaginary. There is no graph, not even a center point. And these special cases do pop up. At least one of them pops up in the homework. They may both pop up. But if you wind up with r being imaginary, you'd have to select there is no graph. It's just not even a point. If r is equal to 0, then the graph is just an ordered pair, namely the center point.
let's do, let me make this. Okay,
So let's
do number 12.
Number 12. I'm hoping it's one of those special cases, but we'll see. Let me write it down. Hey, look at the possibility.
And look at the instructions.
Decide whether or not the equation has a circle as its graph. If it does, give the center and radius. If it doesn't, then describe the graph. The first option, A, that's what we've been seeing. You find the center, you find the radius. For part B, I think that whoever the programmer was for this problem, they just wanted 4 options, because option B, the equation, the graph is a line. I see x squares and y squares. Can linear equations have x squares and y squares? No. So it can never be that B option of a line.
I've never seen it regenerate like that, but if yours regenerates for your number 12 doesn't have any x squares or y squares,
Then you're lucky. Just select
Line.
option B.
And go on.
But option C, the graph of the equation is a point. If that happens, we have to get a 0 on the right-hand side when it's written in center radius form. And part D, the graph is non-existent. Oh, someone's trying to be fancy. What is this non-existent? Why couldn't they say there is no graph?
It's just a blank graph, not even a point.
Not even a point.
But
so
the instructions makes it sound like you just look at the problem and decide.
You cannot decide.
You've got to go all the way through it until you find that radius. That's when you decide. Is it a circle, a point, or non-existent?
You go through completing the square, and at the end, if the radius is positive, it's a circle. If the radius is 0, it's a point. If the radius is imaginary, it's not even a point. That looks like that's a funny looking 10. Hey, am I going to have to divide through the way I did that last problem? Remember on that last problem we had to start off by dividing through? Are we going to have to divide through here? No, because we already have the leading coefficients of 1. We group the x terms together. That's an x squared plus 2x plus skip some space. I like your horizontal approach, Tony. I have to write small. Now we group the y terms together. Y squared minus 10y plus skip some space. What have we got on the right-hand side? Negative 35. But we have a blue blank that we have to fill in and a green blank. People have a tendency to forget to put the numbers over on the right-hand side. So I think that's putting those blanks on the right-hand side the way my brother said to do. It's a good idea. Even if it means I have to write smaller, I still think that's a good idea. Okay, what number's going to go into that first blank, in the blue blank? Do the arithmetic in your head and tell me the number I'm going to write here.
Take half.
Half of 2 is 1. 1 times 1 is 1. So we stick a 1 in the blue blank. Now tell me what's going to go in the green blank beside the y squared minus 10y. Okay,
5. Good.
10 divided by 2 is 5. 5
Five.
times 5 is 25. So, and now I'm going to factor the x terms. Let's factor the y terms. And we'll combine those numbers on the right.
Why don't we combine them right now?
Yeah, let's see. That's a negative 25 plus
Negative
1,
35.
negative 35 plus 1 plus 25. I was thinking this was going to be a special page. Oh, it is. Wait a minute. That's a negative 35. Wait a minute. This is working out very nicely. Negative 35 plus 26 is, I'm getting a negative 9. What can we conclude? Hmm?
What about the radius?
It starts with an I. Imaginary.
Yes.
That's why I'm not even wasting. Well, you know something? I think y'all want me to fill in these parentheses. You confused them by having me jump there, okay? They want me to factor this thing the way I said I normally do. It factors as x sine plus number. Okay, and now the y's here.
Y.
Minus 5. And over here we have a negative 9. So if this were a circle, the center would be negative 1 comma 5. But when we try to take the radius, you take the square root of negative 9. That is imaginary.
It's 3i to be exact.
So there is no graph.
Not even that point. Okay?
Nothing, no matter what you plug in for x or y, you're never going to get a negative number, because no matter what happens here, when you plug that in and square it, what sort of a number are you going to get? Whether it's negative or positive, when you square it, you're going to get a positive plus positive. Positive plus positive can never equal a negative. So we choose the option, there is no graph. Or the graph is non-existent. Someone's trying to sound fancy. All that effort just to say the graph doesn't exist. Do we have another one?
Let's do number 13.
Number
It's another one that might be one of these special cases.
Am I going to have to divide through like I did on that number, what was it, number 10? Number 10? What do y'all think? Am I going to have to divide through here? Minus 6y?
I think number 10 is the only one where they have to divide through.
Mm-hmm. Okay, x squared plus y squared minus 4x. Might make sure I don't miscopy. Okay, switch to my paper. I'm going to group my x terms together. I have an x squared minus 4x plus, skip some space. We have a y squared minus 6y plus, skip some space. What have we got on the right-hand side? What have we got over here on the right-hand side? Okay, we moved that 13 over. It became a negative 13. But I still have the brown space and the green space. And once again, I think it's a good idea doing that, because people have a tendency, students have a tendency to forget. They'll add the number here, but they won't add it over here, and they'll wind up with the wrong radius. Okay, what's going to go in this brown spot beside the x squared minus 4x? X squared minus 4x is,
Not is.
I mean, x squared minus 4x
Okay.
plus half of
Answer what he intended to ask, not what he actually asked.
x
Okay.
squared minus 4x plus 4, okay? Y'all see? She took 4 divided by 2 is 2, 2 squared is 4. Okay, here, what's going to go in? Oh, wait a minute. There's something else I need to do with that 4.
That's why I used to write it like this.
Okay, you see, I got to remember to do that for next semester. Here, okay, 6 divided by 2 is 3. 3 times 3 is 9. There and there. Okay, and now let's factor. Let's factor the x terms. What will I have inside the first set of parentheses? I'll get us started. X minus, I agree, variable sign, half of that number, plus, now let's factor the y terms. Y,
Plus or minus. Oh, look at the next sign.
y, the next sign is a minus, and here 3, okay, variable sign, half of that number. What have we got on the right? Negative 13 plus 4 plus 9, that's negative 13 plus 13. We have an r squared value of 0. So the center, change sign, but what's the radius? 0. The square root of 0 is 0.
So do we have a circle?
We plot the point 2, 3 on the graph. But how much do you move up, down, left, right? It's just a point. The graph is nothing more than the center point. Graph is center point, nothing else. It's not a circle. All they want you to do is say that the graph is a point. But we can be more specific. It's actually the center point that you get from the center radius form.
Number 14, we start reviewing. Let's go back and do number 11.
Okay. Is it a complete the square?
Mm-hmm.
Number 11. Let me write this down. X squared.
So if you see 0 on the right hand side, just when you look at the problem, do you know it's going to be
No,
because
only if it's in center radius form.
you're going to move the 33 over and stuff. So at this point, you can't decide anything just looking at it. You've got to have it written with the parentheses. Or once you've completed the square.
You have to complete the square. You can't tell whether it's going to be you can't say, oh, that's a 0, so it's just a point. No, that's only true if it's in center radius form. It has to be.
That one has the 0, but it was no graph. And once
That
you
one
got
had
it,
a 0, but still, this one here, number 10 started off with a 0 on the right-hand side, but notice it was definitely a circle ending up with a radius of 1. So just because you start with the 0 there doesn't mean that you're going to have something that's not a circle. Group the x terms together.
Oh, wait. Did you check and make sure you didn't miscopy
Oh, I better.
anything?
X, yeah, 2x. No, I did not.
Okay. Lower.
X squared plus 12x plus, skip some space. Then I group my y terms together. Y squared. What am I going to write here beside this y squared? I just am curious if y'all are following what I'm doing. What am I going to write here?
Plus 2y.
Plus 2y, I agree. Plus, skip some space. What have we got on the right-hand side?
33, or negative 33.
Negative 33. And we can't say, oh, that's negative, so it's not even a point. There's no graph. Not until you get it into center radius form. We're going to have the brown blank, although that brown looks like black, doesn't it? Does the green look like green? Does this help? Nope. I think it's just going to make me have shadows. Okay. Do your 2 little steps to tell me what number I'm going to put beside the x squared plus 12x. 36. 12 divided by 2 is 6. 6 squared is 36. Put it into both of the brown spaces. What's going to go in the green space? What's going to go beside y squared plus 2y? Half of 2 is 1. 1 squared is 1. I agree. We can then factor the x terms. What's going to go in those parentheses?
X plus
6, I agree. Variable sign, half of that number, plus y plus, I agree with the variable sign,
1.
half of that number is 1. And what have we got on the right-hand side? So this is going to be one of our special cases? No, I don't think so. I think that we can, this is negative 36 plus 37. That's a positive 4. Okay, so what's the center? Negative 6, negative 1. What's the radius?
2.
I couldn't hear you.
2.
2, I agree. You took the square root of 4, which is 2. And coming over here. So this is one that you don't have to graph either. They just want you to describe it. So which option would I use? A, B, C, or D? I couldn't hear you. I heard someone say something.
C.
C, I agree. So the center is
Negative 6.
negative 6, common.
Negative 1.
Okay. And the radius is 2. Any questions there? And I think 14 starts back with old material.
Cut
The
points.
cut points. Remember I told you, once we start the cut point process,
Uh-huh. I saw your hand up.
So it's like after we've done all these problems, it's kind of like doing it the other way around.
that's exactly what we're doing. We're going one way, and then we go in reverse.
The other way around.
Yeah, that's right. That's how algebra always is. Well, you go one way, then you go the other way.
Y'all want to do number 4? Remember the easy stuff we were doing at the beginning? When they give you the center and
The other way around.
Okay.
when they give you the center and the radius, y'all remember that? Y'all want to do another one just to remember the easy stuff? Or do you think you got it? Oh, you're closing up? Okay.
Click. Go ahead and cut it off.
Oh,
Okay. Stop the recording.
okay.